Hello everyone, this is the fifth part of Calculus 1 midterm exam questions. This part includes 5 nice questions from previous Calculus 1 midterm exams. And let's look at the first question. Suppose that the values of f prime of 4, g prime of 4, g of 4 are given, and g of x is not equal to 4 when x is not equal to 4. When you look at A and B, you first see that we have two limit questions, right? But they are not actually limit questions. This problem is related with formal definition of derivative or limit definition of derivative. So this is why I want to first remind you two definitions of derivatives, okay? Derivative. The first definition is limit when h tends to 0, f of x plus h minus f of x divided by h. It is the first formal definition. The second one, z tends to x, f of z minus f of x divided by z minus x. Okay? When you look at A and B, you see that they are very similar to the second formula or second definition of derivative, right? But they are slightly different. So let's focus on A first. Okay. Let's say if we have limit of f of x minus f of 4 divided by x minus 4 when x tends to 4. What's the meaning of this expression? It means you have derivative of f at the point 4, right? But we actually do not have this expression in A. So we should rearrange the expression. I want to clear again. So this is equal to limit x tends to 4. So I want to divide numerator, both numerator and denominator, by x minus 4. We have f of x minus f of 4 in numerator divided by x minus 4. G of x minus g of 4 from the question. I also have to divide this expression by x minus 4. When you look at the numerator, you see that we have derivative of f at the point 4 from the formal definition of derivative. When you look at the denominator, you have derivative of g at the point 4. What is f prime of 4? This is 3 from the question, and g prime of 4 is 7, and the answer is 3 over 7. Now let's look at the second one. I will exactly use the same idea, but the question is slightly different from the first one, from A. X tends to 4 here. So we have f of g of x. This is composition of f and g. Minus, instead of 4, see we have 4 inside of the parentheses. If you look at the question, you see that g of 4 is 4, right? So you can write g of 4 instead of 4. This is why we have g of 4 here. So it becomes f of g of 4 divided by x minus 4. So what's the meaning of this expression? The meaning of this expression is that we have derivative of f of g of x. It is the composition of f and g. Let me clear this part. We have derivative of f of g of x at the point 4. So from the chain rule, we have f prime of g of 4 times g prime of 4, right? From the chain rule. What is f prime? What is g of 4? From the question, g of 4 is 4, right? This is 4. 4. What is f prime of 4? This is also given. This is 3. F prime of 4 is 3. G prime of 4. G prime of 4 is 7 from question. So we have 21. Two nice applications of formal definition of derivative. Let's continue. A nice question about derivative, about the relation of continuity and derivative actually. A piecewise function is given here and the critical point is 0. Which one of the following statement is true for the given function? You may have this kind of questions in multiple choice exams also. The first choice is f is continuous at the point 0, so we should check the conditions of the continuity. We have three conditions of continuity. F of 0 must be limit when x tends to 0 to the function, right? So what is f of 0? First, f of 0 is given here. When you plug 0 here, you have 5, right? This is 5. So what about the limit? Do we have limit? Does the limit exist or not? Let's look at the limit from right and left. Limit from left when x tends to 0. The function is 5 minus 2x. So the answer is 5. Limit from right, the function is x squared minus 2x plus 5. When you plug 0, you have again 5. Since the limit expression is equal to 5, this function is continuous at the point 0. No problem. So this is true. What about B? Is f differentiable at the point 0? To check differentiability of the function, of the piecewise function, we have to check differentiability of the function at the point 0 from right and left. So let me write derivative of this function. F prime is equal to, when you approach from left, derivative is minus 2. When you approach from right, you have 2x minus 2. Okay. Is it differentiable at the point 0? Derivative from right and left are equal to each other. What do you say? Yes, derivative of left hand side and right hand side at the point 0, don't forget, are equal to each other. Derivative is minus 2. When you plug 0 here, you only have minus 2. Okay, so this is also true. What about C? Is f prime continuous at the point 0? We should also check three conditions of continuity. F prime of 0 is from here minus 2, right? Limit, let's say this is g. Let me change the name of the function. Okay, g of 0 is minus 2. Limit when x tends to 0 from left, g of x is equal to, from left you have minus 2. From right, this is the function. From right you also have minus 2, right? Since the limit expression is equal to minus 2 and g of 0 is also minus 2, the limit expression is equal to g of 0. This is why g function, that is f prime function, is also continuous at the point 0. So all of them are true. Let's continue. For which values of a and b does the following equation hold? So we have a limit question, and the answer of the limit is given. So what do we have? When x tends to 0, when you first look at this question, you have a here. When x tends to 0, this part tends to infinity, since b can be any number, and you have something here. So I think it's the first step. The first step is to substitute the denominators, make them equal to each other. So let's continue from here. Limit, this expression is equal to limit x tends to 0, sine 2x plus ax cube plus, I make denominators equals to each other, bx, only bx, divided by x cube. Okay. When x tends to 0, then if you check, this goes to 0, this goes to 0, this term goes to 0, denominator goes to 0, then you have 0 over 0 case, right? 0 over 0, indeterminate form. So we should apply L'Hopital's rule first. Limit x tends to 0. I apply L'Hopital's rule. Derivative of sine 2x is 2 cosine 2x. Derivative of ax cube is 3ax square plus derivative of bx is b, divided by derivative of denominator 3x square. Okay, let's check. When x tends to 0, this expression tends to 1, this expression tends to 0, and we don't have any information about b. Denominator also tends to 0, right? But we know that from the original question, the answer of this limit is equal to 0. It is given in the problem. Okay? So, what can we say? We see that denominator goes to 0, no problem. Okay? This term goes to 0. Okay? And cosine 0, we have 2 times 1, which is 2. So, if I want to have 0 as an answer of this limit expression, okay, b must be minus 2. What is the reason? B must be minus 2. If b is not minus 2, let's say if b is 5, for instance, if b is 5, you have 0 here, you have 2 here, right? 0, 2, 2 plus 5 is 7, numerator would be 7, denominator tends to 0, so the whole expression tends to infinity, right? Tends to infinity. But in the original question, the answer is 0, not infinity. This is why b must be minus 2. If b is not minus 2, if b is any number which is not minus 2, then you have infinity. Okay, this is the crucial point of the solution. So b have to be minus 2. So we know now what is b. Okay, so let's continue to apply L'Hopital's rule. One more step. If b is minus 2, then we have 0 over 0 case again. So we can apply L'Hopital's rule. We can continue to apply L'Hopital's rule. Derivative of 2 cosine 2x is minus 4 sine 2x plus 6 x. We don't have here, the derivative of minus 2 is 0. Derivative of denominator is 6x. Okay. Now let's look what's happening here. When x tends to 0, this part tends to 0, right? This part tends to 0. Denominator tends to 0. We again have 0 over 0 case. Let's apply one more again. When x tends to 0, derivative of numerator minus 8 cosine 2x, derivative of 6ax is 6a, derivative of denominator is 6. When x goes to 0, you have 1 here. Finally, you have minus 8. Okay. And minus 8 plus a. Okay. Minus 8 plus a, let's say minus 8 plus 6a divided by 6. And we know that from the question, this expression is equal to 0. It is given in the original question, the green equality. Right hand side is 0. So this limit must be 0. It means minus 8 plus 6a must be equal to 0. From here, a is equal to 4 over 3. And we found b. b is minus 2. So what's the meaning of this? If a is 4 over 3, b is minus 2, and this limit expression will be 0. Okay? It's not so easy question. I agree with you. Let's continue. We have two nice limit questions. In order to solve this kind of limit questions, we should familiarize with some trigonometric identities. Okay. The first one that I want to remind you that cosine 2x is equal to cosine square x minus sine square x, right? We have this trigonometric identity. If I change this equality, if I write 3x here, okay, it means I have to write 3x over 2, 3x over 2, right? Okay. And if you subtract 1 from left hand side, let me write this expression first. Minus sine squared 3x. So I have to subtract 1. So instead of 1, you can subtract cosine square plus sine square, right? Cosine square 3x over 2 plus sine square 3x over 2. Let's continue. If you substitute right hand side of the equality, you see that you have minus 2 sine square 3x over 2. So cosine 3x minus 1 is equal to minus 2 times sine square 3x over 2. So what do I compute this trigonometric identity? What do I have this trigonometric identity? If you have square root in the limit questions, I strongly advise you that multiply the limit expression by the conjugate of the square root function. So let's go back to the original question. This limit is equal to, I want to multiply by its conjugate, limit x tends to 0, square root of cosine 3x minus 1 divided by x sine 2x, x sine 2x. I want to multiply this by the conjugate of numerator. So you have square root of cosine 3x plus 1, it is the conjugate, divided by the same expression here, cosine 3x plus 1. Okay. From a square, let me remind you, from a minus b, a plus b, you have a square minus b square, right? So let me continue to solve the question. When x tends to 0, numerator will be cosine 3x minus 1 divided by x times sine 2x times cosine 3x plus 1. Okay? So, instead of cosine 3x minus 1, I computed the trigonometric identity, this one, I will use that one. Minus 2 limit x tends to 0. The denominator is the same. X sine 2x cosine 3x plus 1. So instead of cosine 3x minus 1, we have minus 2 sine square 3x over 2. Okay. So the rest is, the solution is not short. X tends to 0. So instead of, I can write minus 2 here. Okay. So we may have sine 3x over 2 divided by 3x over 2. We have x here, so I multiply denominator by 3 over 2. This is why I have to multiply this expression by 3 over 2 times sine, again 3x over 2, since we have square here, divided by 3x over 2. So I multiply this expression by 3 over 2 times, I know we have an x there. Okay. Times limit 2x, since I multiply denominator by x, I multiply numerator by x also. We have 2x sine 2x from here. Since I multiply by 2, I have to divide by 2. And finally, this expression, limit 1 over square root of cosine 3x plus 1. X tends to 0. When x tends to 0, this part tends to 1, this part tends to 1, this part tends to 1. And finally we have minus 2 times 3 over 2 times 3 over 2 times 1 over 2 times, when x tends to 0, this is 1. 1 plus 1 is 2. So you have 1 over 2 here. And the final answer is minus 9 over 8. Okay? So this is all. What about b? You actually use the same idea to compute b. Let me solve b here. I multiply numerator and denominator by the conjugate of denominator, right? If you multiply by the conjugate, you have limit x tends to 0 sine 3x times 2 plus square root of 4 minus x divided by x, only x. So you can rearrange this expression. Sine 3x divided by 3x. Since I multiply denominator by 3, I have to multiply numerator by 3 also. This expression is multiplied by limit x tends to 0. The rest, what do we have? This expression. 2 plus square root of 4 minus x. And when x tends to 0, you have 2 here. 2 plus 2 is 4. So finally you have 4 times. This expression tends to 1. 4 times 3, which is 12. So, and the final question, find derivative of this complicated function. If you apply derivative rules to find derivative of this complicated function, it will take long. It will be very long to have the final answer. So if you have this kind of complicated functions, I advise you to take ln of both sides first. Ln y is equal to ln of right hand side, and use the properties of logarithm function. You have, if you, okay, I want to apply properties of, I want to remind you the properties of ln. What is ln? A times b divided by c times d. This is ln a plus ln b minus ln c minus ln d, right? ln d. So I want to use this rule. So we have ln x plus 1 over 2 ln x plus 1 plus minus, 1 over 3 ln x plus 2 minus 5 ln x plus 3. Okay, so derivative of left hand side, now let's differentiate both sides with respect to x. Derivative of left hand side is y prime over y. Derivative of right hand side, step by step. Derivative of ln x is 1 over x. Derivative of second expression, derivative of inside over inside. Derivative of inside is 1 over inside. Derivative of this expression, we have minus 1 over 3 as an coefficient. Derivative of inside is 1 over inside minus 5. Derivative of inside is 1 over inside. So it is all.